understanding. You see the problem. No. Oh, what's wrong? What's wrong? What's wrong? Okay, no problem, no problem. Okay, that's how to use the calculus, basically. How to what even the meaning of the linear approximation even mean? That's what I want to emphasize in this example, because you know that when we heard the teacher teach, usually it's just, oh, okay, I get it, but when we do by ourselves, it's like, hey, I don't really understand what it means. You get it, right? That's okay. It's number 45, right?
44.
44. Sorry. Okay. Yeah, okay. Do you want me to discuss now, or someone needs more time, or what do you think? Boss? Everybody can listen to me. Yes. Okay. Okay. So yes, we will discuss that. We will discuss. Ah. So, well, there is some ways to answer this question, and there is a way that we can answer this question without calculus, to be honest, because, well, you know, right, the what? Okay, the volume of hemispherical dome is, let's say, 2/3 phi r radius power of 3, right? Okay, so it is a function of phi from r, and we know here the r is 25 meter, and now what is pain? We can see pain as a volume. So even without calculus, we can calculate the pain by using that phi with pain minus phi without pain. Okay, it's become 2/3 phi. The pain thickness is 0.05 centimeters. So what it is in meter?
0.0005.
Oh. So delta R is 0.05 centimeters, or 0.05 times 10 power of minus 2, right?
Yes.
Meter. Well, you can do this 25 plus 0.05 10 power minus 2 power of 3 minus 2/3 phi 25 power of 3. Well, but I think in the exam you cannot use calculator, right? Not sure.
I don't know.
Okay. Even with calculator, this number is not nice. So with calculus, we can have something nicer. So what calculus say? Calculus say that basically we can approach. So what is? So we want to find the volume difference, right? Volume with pain minus volume without pain. So basically, what we want to find is delta V, right? So calculus say that what? Delta V over delta R is can be approached as, I forget. Do you remember from the book? Let us see. Well, they don't write in the book, but I think basically we assume that this is more or less this is can be approached by dv dr, right? So, but we know what is dv dr. That's quite easy. What? It is 2 phi r square, right? So dv is basically 2 phi r square dr. So delta v is more or less dv equals to 2 phi r square dr. And well, that's, we just plug in. R is 25 square. And what is dr? dr is 0.05 times 2 of minus 2, 10 power minus 2. Well, the number is a bit better, but not so good. So we have 6.25. Okay, sorry. It's 625 times 0.1 times 10 power minus 2 times 5. So that 10 power minus 3. So it's like 0.625 phi in what? What is the unit? It is what? It is volume, right? So the unit is m, meter cubic. So, oh, sorry, it's disappeared. Meter cubic. So what I want to show to you is, this is basically what we mean by linear approximation. And why we use linear approximation? Because, well, you can do without calculus, but much harder. And with calculus, it's quite short, right? Quite short and easy. Okay, so the error, do you, any of you remember what is the, how to find the error? No? Well, okay, the concept of error is something like this. Okay, okay. Why dvdr is, no, no. dvdr is 2 phi r square, not 2 over 3 phi r square. So, I mean, it's calculus. So, so basically, yes. This is phi, right? This is phi. This is phi. This is phi. So, what is dvdr? dvdr is d of 2 over 3 phi r cubic to dr, right? It's just, well, because it's power 3, so it's become r square, and the 3 is go to the front and times 2, so 2 over 3 times 3 from here, and times phi. So we have 2 phi r square. So there is no 2 over 3, but 2. So basically, it's, if you remember the volume of the ball and the, what is you call it, the circumference of the ball or circle, it, do you notice that circumference of the ball or circle is just derivative of the volume or the area of the ball? You get it? So we have volume of the ball, volume of ball is 4 3 phi r cubic, right? And the area of the ball is 4 phi r square.
Got it.
Yeah, remember that? It's basically, the area is just the derivative of the volume. Okay, do you get it now? Yep.
Much more easy than
Yep.
my original solving.
Yes. Okay. Okay, can we proceed, or do you guys want to ask something? So basically, the B part, what is error involved, the concept is something like this. The volume is not linear, but we approach with something linear. So in the book, there is a nice picture that I want you to get. Let's share. Do you see figure 6? So the function is the blue one. It's not linear, but from very small distance from the point, you can approach with the linear line, the red line, the function in the blue. So there's difference here. So the difference is basically the error. something like that. But it's not that hard to do just 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 basically you find the dv the hard way, and from this dv you minus this part with 0.70 to 155, so you get the error. You get what I mean? So basically error error here is delta v minus dv. We have dv here, and delta v you find in the hard way, and you will find the error. Okay, so far so good, right? Okay, if not, I want to proceed to okay, you have learned about maximum minimum, that's fine. So I think there's not much maximum minimum value problem yet, because the problem will be appear in 4.7. Okay. So you might try these two problems, and I think 15 minutes from now we will discuss it. I think this kind of problem that you never find in the high school, right?
Yes.
Yeah. I mean, well, obviously we only have 1 hour tutorial, so you must do problem by yourself outside tutorial. But in this tutorial, I try to open your eyes to some new problems, more to some new ways to see the problem. And if you want to ask something, just write or open your mic so I can hear you. What do you think? The mean value theorem is easy, right?
Then, probably.
But the no local maximum or minimum may be a bit harder. So if you finish before the time, please let me know because well, this not hard problem. It's just uh, you never, most of you never see this kind of problem, so it's a bit. You need to think more about how to solve this problem. Do you get it?
Maybe.
Okay. Anybody has finished this? No? Okay, good. So basically, the first part is prove the function la 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 has neither local minimum or local maximum. So what is local maximum or local minimum is when df dx equal to 0. So we must prove that there is df dx. We must prove that df dx cannot be 0. Can be bigger or smaller. So what is df dx? Df dx is equal to 101x power 100 plus 51x power of 50 plus 1, right? Now, we get these two power of even number. So what does it mean? It cannot be negative, right? This part can be negative. And this part is 1, so it cannot be it's positive. So positive plus positive must be bigger than 0, right? It's the minimum value is 1 when x equals 0 and cannot get lower from that. So yeah, so there cannot there is no df there is no point such as df dx will be 0. So there is no maximum or minimum. Okay, now mean value theorem. I think everybody remember, right? Let's draw. This is sine. Sine 0 is 0, something like this. And we have, let's say this is A, this is B. And from mean value theorem, we know that we have point C. There must be a point C. Doesn't need to be in the middle, can be near A, can be near B, somewhere between A and B. So such as that there is C such as the derivative of point C equal to F FB minus FA over B minus A. Maybe it should be B here, A here, but it's just the same, right? Because it is the absolute value, so it doesn't really matter which one bigger, A or B. Now, what is F? Fx is sinus x. So the derivative of x is cos x, right? So we must have that cos C such as sinus A minus sin B. Well, in the exam, you must write something better than this, right? I just don't have time for doing something better than this. Over A minus B. But we know that the maximum value of cos is what? Is 1, right? the maximum value of the absolute of cost is 1. So we have that this value must be smaller than or equal than 1. So we have sine A minus sine B divided by A minus B must be smaller than 1. Must be smaller or equal than 1. Multiply both left and right with A minus B, and we get the answer. Okay, it's quite easy. Is it clear or not? I think it's clear, right? So I want to revisit the first part, this part, because it's such a mess. So what I want to say is, first, what is us in A is delta V. But the problem is we are lazy, or yeah, basically we are lazy. So we approach delta V with dV. Because we know what is dV, we know what is dV dr, right? Some function of r. So we know dV is this thing times dr. Times dr. Okay. That's good that we are being lazy, and we can be lazy because of calculus. But the B part is the not so nice part. Basically, here we have dV can be approached, delta V can be approached by dV, but obviously, for most cases, delta V is not the same as dV. So we have error. Basically, that is delta V minus dV. The absolute value, because we don't care which one is bigger than this one, because error is error. Because our dV doesn't actually match with delta V. I think that's the point of linear approximation. You guys will learn more about approximation next semester. And next semester, it's not just only linear approximation, but with higher approximation to get more accurate approximation. But for most cases, linear approximation is good enough. Okay. So far, so good. Any question? Or no? I think if not, I think that's all for today. Thank you very much for coming in this tutorial. If you want to ask something, you can ask now or later in the Moodle. Either message me or just in the discussion box. You can ask there. So maybe some of your friends can answer the question, or maybe me can answer that question. I think that's all for today. Thank you very much for coming. Welcome. Bye.